Hi, and thank you for joining. We are discussing differentiability in functions. So, we took a look at a couple of examples to discuss the different types of differentiability. We said that the function is non differentiable at a point if the function is undefined, like in this example. The function is discontinuous at x equals -1, and we explained algebraically what it meant and how to explain or how to connect it with the fact that you cannot draw a tangent, you cannot find the slope of the tangent, you cannot find the derivative. And when we looked at the equation of the derivative, we saw that the derivative function had a restriction at that same point where the function was discontinuous. The second type of non-differentiable functions are the ones where we are able to draw the tangent, but the tangent has an immeasurable slope, like the square root function. And the last case we discussed were what we call the corners and the cusps. And the absolute value functions are examples where the graph of a function presents a corner, and we said that at this point where the corner is located, the function is non-differentiable because the derivative cannot be measured. The reason why is because if we are at x equals 0, so at the corner, you can present the rate of change in here as a rate of change that follows the trend in this part of the graph, so that can be a negative rate of change or it can be a positive rate of change, right? So because we can refer to the rate of change at this point at both sides of the graph, which means that there are two different rates of change at the same point, we say that the rate of change is not a definite number, so we don't know the value of it, so the function is non-differentiable. That's a graphical explanation. Algebraically speaking, we are going to try to find the derivative of this function at x equals 0, where the function is not differentiable, and we're going to see what that looks like in an equation, so in an algebraic solution or explanation. So obviously, to find out if the function is not differentiable at 0, we will have to attempt to find the derivative. We're finding the derivative by using the first principles formula, the limit as h approaches 0 of f at, we are finding the derivative at 0, so 0 plus h minus f at 0 divided by h. This will take no time, by the way. So we have the limit as h approaches 0. We'll bring in the function, so absolute value of x. So instead of x, here we have 0 plus h, which means that we'll have the absolute value of h minus absolute value of 0 is simply 0, and divided by h. So if you want to see this, actually, I'm just going to bring 0 plus h exactly just to be sure, but I'm pretty sure you see this. So limit as h approaches 0. So we have absolute value of h divided by h. We have to find this limit. Obviously, we cannot substitute h by 0 because we get an indefinite limit. So we have to think of evaluating or simplifying the h from the denominator first. So obviously we cannot simplify the h from the denominator because the h we see in the numerator is inside the absolute value, so we need to remove the h from the numerator first. So we are going to say that to remove the absolute value, we need to consider the values of h inside it. So we say that the absolute value of h would be equal to h if h is either positive or equal to 0. So if h is a negative number, we said that the absolute value of h will be the absolute value of a negative number, right? And we know that we have to come out with a positive here, so we have to take the opposite of this. So therefore, we're going to say minus h. So this will turn into sort of a piecewise function on its own, so this very expression in here, which means that if we want to remove the absolute value, we need to take both left and right hand side limits. So we'll break this limit down into two parts, or into two limits. So we'll find the limit as h approaches 0 from the right of absolute value of h over h, and we'll find the limit as h approaches 0 from the left hand side of absolute value of h over h. Now, remember that if h is approaching 0 plus, it means that h is bigger than 0, which means that the absolute value of h would equal itself. So therefore, we'll have here the limit as h approaches 0 plus of h divided by h. Now, h divided by h simplifies to 1, and that would be the limit as h approaches 0 of number 1. And as you can see, number 1 is not dependent on h. I'm going to add the 0 plus in here. It won't make much of a difference because we have the limit of a constant which equals 1. So if you find the limit as h approaches 0 from the left-hand side, it means that the value of h will be some negative number. So if h is a negative number, it means that the absolute value of it will be the opposite of h. So when we remove the absolute value, then we'll have to write negative h instead of absolute value of h. And you see that the two h's here will simplify to leave us with the limit as h approaches 0 minus of negative 1. So that's the limit of a constant, so that's equal to negative 1. And as you can see, the limit on the left-hand side is different than the limit on the right-hand side of h, which means that these two limits are different, left and right are different, which means that the limit at h equals 0 doesn't exist because the limits don't agree. And we have mentioned this before. We've said that if the limit on the left and the right don't agree, that means the limit doesn't exist, which means, because this is the limit that helped us find f prime, which means f prime doesn't exist. And that agrees with the graph of this function, because as you can see, when you approach 0 from the left-hand side, the rate of change of the function is negative 1, and when you approach the 0 from the right-hand side, the rate of change of the function is positive 1. And this is what the algebraic solution of a corner would look like in the absolute value functions. I hope this made sense, and I hope that will prepare you well enough to complete the exercises for this lesson. For now, I would like you to just leave out the question number 4. We are going to revisit this in the next unit when we discuss the chain rule as well. I hope this made sense. Have fun learning, and thank you for watching. Bye for now.